So we actually wore fireproof overalls during the event. I mean, like, it's not so appropriate now, but everyone within the boundary was supposed to wear these to stop being on fire. Fortunately, they were not necessary. So they're actually oil rig workers' boiler suits, I think.
It's a work of genius, clearly. Crazy, insane genius. Where did it start? Where did the idea come from? And how did you get going with it?
Some years ago, I was fortunate enough to go to Burning Man, and I saw lots of fire art there, and I thought, that sounds like something I kind of want to do. So I've had this thought in my head for a while to do that. 2 years ago, the previous EMF camp, we did a big collaborative project. Many members of the space contributed, and we made Barbot, which is a cocktail making robot. And when it came around to this time, I thought maybe do something with fire. I was down in London and having a drink with Jonty, one of the EMF organisers, and I wanted to ask him if it was okay to do fire at EMF, because it's kind of potentially risky. And his response was, yes, yes it is. And in fact, he'd already been sort of experimenting with these sorts of little flamers, and he suggested Pong as a game, and so we just sort of took it and ran with it, and it sort of came to fruition that way. There was lots of experimentation, lots of broken things, mainly Arduino Pro Minis.
Went through a few 485 drivers as well. There's something not quite right with that to start with.
Yeah, burned out a few bits of electronics.
One of the things we had to work out how to do was how to light the gas. So we experimented with things like barbecue lighters, but they weren't really that effective. Then I came across these things, £1.64 from eBay. You put 5 volts in, you get a few thousand volts out. And then another challenge we had was how to design a spark gap. We needed some insulators, but ceramic tubes were really expensive to buy. So we've got a couple of ceramic tubes from Fuses here with screws in the ends and a machined aluminium block which just mounts to the right position. We initially just had round-headed screws in here, but we found that we didn't get a good spark between them, and the actual high voltage generators were wearing out. So we did a bit of research and found that sparks form better off sharp points. So we ended up with these little strands of wire here which just sort of encourage it to generate a spark, and that also means that the spark is over the end of the where the gas comes out.
Was it difficult to make the game work as a game rather than the engineering side of it, or was that fairly straightforward?
Yeah, we didn't know if it would actually be fun to play when we made it. I mean, I just wanted things to be on fire, so I didn't really care too much about the sort of actual gameplay until quite late in the process, and it turned out it kind of worked pretty well. It was more or less my first sort of implementation of a game of Pong, which was really a placeholder for something a bit more sophisticated, but it sort of worked, so we just built around that.
Well, there was a bit of discussion about what would happen when you won, wasn't there? 'Cause we didn't want to encourage people to lose, we didn't want to encourage people to win. So that was when the victory swipe came, wasn't it?
That's right,
to encourage people to want to win and to have that extra go and make more fire when you win.
People really enjoyed the victory swipe, I think. It was a successful strategy.
Now you two are expert plumbers, right?
Well, I wouldn't say about expert plumbers, but we certainly learned an awful lot about different gas fittings on this project. Because some of the nuts and some of the joints are left-handed, some of them are right-handed, and a lot of it's imperial. All of this section, that's all on what's called quarter-inch BSP valves, but nothing is actually a quarter-inch. Quarter-inch was what used to be the inside diameter when they have very thick walled pipes. But now, although you can buy a quarter-inch BSP pipe and quarter-inch BSP fittings, there's no measurement on there that is actually a quarter-inch, which is really, really weird.
It's very satisfying to put together because it's really heavy and chunky. Yeah. And I'm a sort of software guy by trade, so...
One of the challenges we had was all the gas hoses are left-handed threads, but a lot of the other fittings are right-handed threads. One of the challenges was trying to find the missing component which allows us to convert from left-handed to right-handed, and that took quite a while trying to get that. Anyway, we found a source of them. Weren't cheap, but we did find a source of those.
We did actually have a few parts custom CNC made as well. The adapters for the butane tanks into the rest of the pipework. The thread on a butane tank is not something which is generally... you can't buy parts which go into it, basically. There's the kind of valve that comes with the cylinder, and that's the only thing that goes in. So we ended up having a part CNC made by another Hackspace person. and that worked out pretty good. So the distribution board is actually split into two, so we have two separate pressures. The main supply comes in here, and we run this up to 4 bar, and so we have a 4 bar gauge here. And then there's a second regulator here for the small puffers to come off, and that has a separate pressure. We actually want them to run as low as possible because we get a nicer quality of flame. It acts more like a sort of torus of flame, and then you get a smoke ring coming off it. If it's at low pressure, if you run it at higher pressure, you tend to have a sort of turbulent flow, and it doesn't look as sort of visually appealing. So we can set the pressure of the large puffers and the small puffers completely separately just by adjusting this and the other regulator, which is actually on the tank. So
the small puffers are the, if you like, the ball.
Yes, exactly. They're the puck is how I think of it, sort of going back and forth. The fire pixel, foxel. There's room for a spoonerism there. This is the source of the propane, so this is running everything. It all comes in through this distribution board to the other parts of the system. The other two canisters are actually butane cylinders, which were discarded, and they act kind of like a gas capacitor. They're called accumulators, and they store gas close to where it comes out so that it can come out quickly. From the top of the accumulator, we come through this solenoid valve, and from there it's just 22mm pipe straight up to the end of the barrel. And the idea is to get a fast flow of gas up to where it's burning, so you get a nice big puff. If we didn't have the accumulators, what would happen is the rate of flow would be constricted by the width of these pipes, and these are only 5mm propane tubes, so you can't get much gas through them. And in fact, after we've discharged the accumulator, you can hear it recharging for probably about a minute or something until it's back up to full pressure. So that just it enables us to have sort of a sudden big flow of gas and make a good big flame.
We've got a separate regulator on the side which powers the pilot lights. We've got the constant flame there. It's quite nice when we took it to the EMF Camp Festival, so it gives us a bit of ambient light around the whole area.
The game is really intended to be played at night, so that obviously all the fire looks a lot better when it's dark, but the pilot lights give a really good base level of illumination with everything sort of flickering, and it adds quite a lot to the sort of atmosphere while people are queuing up. And then when you get the big puff, the sudden change in brightness is kind of visually appealing. So the scoreboard kind of gives us an option to actually display something so we can get an idea of what the state of the game is. This is helpful when we're selecting modes. So right now it's saying this is Sparks mode. We have various buttons on the control box. Let us select mode, so setup. And it's kind of a nested menu. Yeah, this is the gas distribution board. We tried to build in accordance with Burning Man fire art guidelines, and one of the things that they say you have to do is to have a single master cutoff valve, which is a quarter-turn valve, so you can quickly shut off everything, which kind of works, except there's still gas in the accumulators, but it works to prevent any more gas getting into the system. And then we can also isolate individual segments, so each large puffer has its own valve, and similarly each of the 3 small puffer segments also has one of these, and it's all as brightly indicated as possible so that we can see it at night under the flickering lights of the pilots, which worked fine. We didn't have to mess with it at all.
There's a 60 amp power supply in here, so when everything's running it could potentially take up to 54 amps, so we're a bit concerned about that. We're concerned about how much current it's using. So looking around the hack space, we're looking for a meter. Came across a box of all sorts of meters. We found this one, which it's got feet per minute on it, but it's actually calibrated with a shunt in here, so it actually reads 0 to 60 amps. But it never goes more than about sort of 20 amps at the most when it's running. 600 feet per minute, but that actually means 60 amps.
That's tenths of an amp, right?
Yeah, I guess so. Yes. Yeah, I guess so. So just a quick look inside here. So inside that's the 60 amp power supply. That creates 12 volts. Then we've got a DC-DC converter, just step it down to 5 here, which powers the Raspberry Pi, which is running everything. And then we've got a RS485 converter here. RS485 is a differential network, so it's more immune to noise.
And because there's interference.
That's right. Well, we've got high voltage out there on the sparkers, and we also got very high current as well. Because we've got high current flowing these cables, we will get a voltage drop, and we're concerned about the ground level shifting. So using 485, which is a differential signal, which goes between 0 and 5, then 5 and 0 as the data sent down the line, that's more immune to noise than RS-222, which is a single-ended system.
And is the Raspberry Pi just running something like Raspbian?
It's standard Raspbian, and then the actual application is written in Python.
Yep, it's all Python on the Raspberry Pi end. The actual communications is done, like I said, over a sort of custom serial protocol, which just describes events. It's only one directional, so it just sends events. There's no acknowledgement that an event has been processed in one of the various nodes. But we've set it up so that there's not an event to say, turn the gas off now. So it may be that an event doesn't trigger some gas coming out, but it should never just leave a valve open and pouring gas everywhere. In that protocol, we have a checksum. So in case there's noise from the sparkers or from the high current, we can detect that a packet's been corrupted and not trigger an event. So in this way, we try to be as kind of robust and safe as we can.
And is that noise the power supply?
Yeah, that's the fan that's inside the power supply that's creating all that noise.
What did you get the power supply from though?
It was off eBay, probably from China, I would guess, but it seems quite reliable. They're IP65 rated connectors, so we want to make sure everything out there was waterproof and just use the same connectors on the control box. And the pins in here are rated to 30 amps. We've potentially got like 20 amps in each segment. And then we've got these 4 control buttons that just wired into the GPIO pins on the Raspberry Pi for controlling it.
Straight out of an arcade one.
Yes, yeah, arcade buttons. That's it. Yeah.
Fantastic.
So most of the time it's just the yellow button, just to restart the game, isn't it?
Yeah, that's for the most part. Once it's in Pong match mode, we require a manual interaction to start the game going, and then the game will proceed until it's finished, and then it sort of waits again for another interaction. So the operators have a time to describe to the players what they're supposed to do. So we have a little spiel that we give people about. Have a practice waft of the bat. And the bats have a haptic feedback.
Haptic feedback
so
from the Wiimote.
They vibrate slightly when you waft them to sort of indicate that you've actually done it right, because you have to give it a little bit of welly to sort of make the Wiimotes detect. It was a bit much for some of the smaller kids. The bats come nearly as big as them. So.
Yeah.
What's the name all about? Rule Zero? Have I missed something with that? Is that a...
Rule Zero is a Hackspace thing. So Rule Zero of the Hackspace is do not be on fire. And that basically means look after your own safety and look after the safety of other people around you. You're responsible for your safety. That's the sort of gist of the rule. Rule Zero of the game has an asterisk next to it, which basically says more of a guideline.
Yeah. So yeah, it was a bit of a play on the Hackspace rule, but calling the game after it.
Love it.
Yeah.
Fantastic. Well, good stuff, guys. And if people want to play this game, will it be anywhere else? Is it going to feature somewhere?
We haven't got anything definitely lined up, but
we've had some interest, but nothing confirmed yet.
Yeah. I'm sure we'll run it again. It's too much for a single event. So.
How long did it take you to make?
Oh, I can't quite remember.
Many hours. I think we started working on it in earnest about 2 or 3 months before EMF. We've been planning for a long time and done sort of little bits of prototyping.
It's quite a bit of prototyping, wasn't there?
And does it cost you a lot, this?
A fair bit. I mean, we got some money from EMF, so EMF has grants for their sort of shiny projects. Yeah.
And some money from Nottingham Hackspace as well.
Nottingham Hackspace also, gave us some funding, but I think that was a bit less than half.
Didn't quite cover all the costs.
Yeah.
It costs a bit more
literally burning money.
And the gas, obviously you're burning gas as we speak. But.
Yeah, the cylinder's £28, I think, to refill a cylinder, and that lasted about 4 hours at EMF camp, sort of 8:30 till half midnight. Yeah.
We use one cylinder.
One cylinder every night.
These are actually pieces of metal stud, which I just got from a DIY shop.
Oh, the sort of brace on the floor?
Yeah, this kind of box section thing. And that's just to keep the pipework from twisting in transit and sort of make it as stable as possible, so that we don't end up getting sort of leaky pipework, so we want to keep it all rigid. And it also acts as a nice conduit for the various pieces of wiring and stuff. close. They do actually stand up on their own, but we put the legs on just to sort of make it much more stable, because we don't know if the ground is going to be level where we're running it. So there's just some butterfly bolts on the top there which you can loosen, and then the feet will sort of twist in so that it's easier to put in the car. The setup process to actually get everything sort of in place and connected to the gas cylinder, probably about half an hour, but then we have a process that we need to go through to flush the accumulators, make sure there's no air in there, and that process probably takes another 15-20 minutes, so probably an hour from sort of putting everything on the floor to actually having fire happening. Obviously, if we're doing it in public, we also need to set up a bunch of fencing. So at EMF camp we had a whole bunch of pedestrian barriers which we sort of laid out in a perimeter around the flames. We tried to have a 5 metre distance between anything that can make fire and members of the public, so it was quite a big perimeter. So it took a little while to set those up, but yeah, it doesn't take too long to put together. Then you've got to wait for dark. Right?
It's a real visceral sound as well, isn't it?
If you're indoors, it's horrifying. When we were testing those in the hack space, it was actually unsettling to be anywhere near them. People would visually back away.
What's going on today though? How many volts
I think the rule of thumb is 1,000 volts per millimetre of gap if you're going to get arcing, so probably 5,000 or 6,000 volts, which is amazing. So we put 5 volts in, and 1,000 times that comes out. It takes quite a few amps at 5 volts to actually power them. That was one of the challenges, was getting enough power to each individual segment. So we have quite beefy cables to be able to deliver that much power. There are many ways in which Fire Pong can hurt you. I think the sparklers are the bit that I'm the most frightened of. I'm not really frightened of the fire. Yeah, I like the fire. This was made by another Notting Hack guy called Jelly, and he participated in the project by making these. Yeah, the first one that we made was twice as big, and you could barely lift it. But these are pretty great. This is where participants were smacking it on the fencing that was in front of them. Got a bit enthusiastic when alcohol is involved. Yeah, so it took a bit of a beating, but they held up pretty well, you know.
Anything surprised you when you've been making this then?
Everything. Yeah, one of the challenges that we had was cooling of the LPG. So inside of the tank, the propane is a liquid, and then as you let the gas out, it boils inside the tank, so you get a phase change, and the liquid cools down really rapidly. And you can actually see that on the tank, that it starts to frost pretty quickly. So here you can see that's kind of the level of the propane in the tank. So we've got through about a third of a tank so far. It's a problem because if the temperature drops too much, then you get a drop in the amount of pressure you can produce. So when it gets down to about, I can't remember the numbers, if it's minus 20 Celsius, then you get down to about 1.5 bar, which isn't enough to really drive the big puffers effectively. So when we were running at EMF camp, we actually had this submerged in a big vat of water, and that just helped to keep it warm enough to keep the pressure up. But it's amazing how quick this effect happens. I mean, like, we have been running for a little while, and you can see the sort of frost on there. But if you're running it hard, this happens really rapidly, and you get a drop in pressure. So,
do you know, I think you're missing a trick here. Do you know what this is?
What's that?
Combined with barbot. You could keep the drinks cold.
We did actually cool our beers at EMF camp in the big vat of water. Yeah.
Fantastic. Anything in the pipeline for next time?
We have some ideas, but we don't know what yet. It depends on the site. Maybe more fire. Yeah, fire is good.
So if people want to contact you about this project, Hackspace?
Yep. Yeah, we've got lots of details on the Notting Hack wiki, including pretty much a comprehensive list of all the parts that we used and how much it cost and where to order things from. Obviously, don't encourage people to set themselves on fire.
Be safe.
Remember Rule 0. But yeah, if people are interested, you can find lots of information there. And if you post to the Notting Hack mailing list, then you can get in contact with us that way.
What we get is an incredibly weird picture of sort of weird hybrid baby things that kind of gives me nightmares. You could argue, in some ways, we're getting an intuition about what the lower levels do and what the higher levels do. Predominantly, it's just for fun. Right? There are other papers.